Hey guys, in this video we're looking at two-step experiments. There's two types, so I guess there's one with replacement and one without replacement. In this context, let's just put it simply with before we go to examples. You have 6 tokens, 1 to 6, and you take one out. Obviously, you've got 6 different options, a 1, a 2, a 3, 4, and a 5, and a 6. And then, so it's a 1 in 6 chance to get a 1 and all the other 5 numbers. You put that token back into the bag and you've reset your chances or the probability of getting the token out and having also 1, 2, 3, 4, 5, 6. Nothing changes because you replaced the token back in the bag. So when you have when you do replace things in the bag, it gives you the chance of having doubles. Okay, you can have as an outcome select 2 5s or 2 6s in a row because you replace that token after you've drawn it the first place. The difference is without replacement, once you've taken it out of the bag, okay, you don't obviously put it back in the bag. That means the chances of having doubles does not exist because you've permanently taken it out of the bag. All right. So then if we were to say what are the possible outcomes with replacement, we're looking here at 6 times 6, which is 36 outcomes. But in without replacement, you've actually got 6 less. So you only have 30 outcomes. Okay, because you're no longer you're no longer replacing the things in the bag. So basically it's 6 times 5 because the first event you have 6 options, and then once you've taken out the bag you only have 5 left. So 6 times 5 is 30 outcomes. All right, so let's have a look at some examples. Now where did I put it? Oh, that's right. So let's look at with replacement. Okay, and in this case we've got 3 red and 2 blue counters. Okay, and they're in a bag, and you're going to take a token or a counter out of the bag at random, and you're going to note down what the color is. And what we could do is we could look at a tree diagram in this case. Before it was kind of like a table. And in your first case here, you have a chance of getting a red and you have a chance of getting a blue. But what is the probability of getting a red? Well, that's a 3 out of the 5. And the blue, the chances of getting a blue is 2 out of the 5. Okay, so you got a 60% chance versus a 40% chance. As I said, really important that you know how to convert fractions to decimals and percentages and things like that. Because you've replaced it back in the bag, the counter, you still have a chance of red, you still have a chance of blue for the second draw. And because you've replaced it, your chances for a red is still 3 out of 5. Chances of a blue is still 2 out of 5, 3 out of 5, and 2 out of 5. Okay, so your possible outcomes are 2 reds, a red and a blue and a red, and then 2 blues. Okay, if we're talking about the order being important. Now, remember, event 1 had 5 outcomes. And when you put the counter back into the bag, you have also 5 outcomes in your second draw. So in total, you have 25 possible outcomes, which range in a combination of 2 reds, a red and a blue, blue and a red, and 2 blues. Okay. Now, one thing I want you to take note of is this. So in order to work out the probability of having 2 reds, you would want to multiply these two together. Okay, so 3 times 3 is 9, and what I might do, I might actually write this down. 3 times 3, and then 5 times 5. Apologies. So 3 over 5 times 3 over 5 is 9 over 25. So out of the 25 possible outcomes, we have 9 of them that you could have 2 reds in a row. Okay, so then what we could do is then, for example, if we wanted a blue and then a red, okay, then we have 2 out of 5 to get a blue first, and then the chances of getting a red next is 3 out of 5. We want to multiply those two probabilities, and we get 6 out of 25 to be our probability of getting a blue and then a red. Okay, if we do the same thing, and let's change the color. So let's say we wanted 2 blues. Okay, then we're looking at 2 over 5 times 2 over 5, which is 4 over 25. And then lastly, let's say if we wanted a red and then a blue, we're looking at 3 over 5 times 2 over 5, which is then 6 over 25. So there's our probabilities of having the sequence of events in terms of the tokens that we have in the bag with replacement. And the last thing you'd want to make sure is that your fractions here all add up to the total. So 6 plus 4 is 10, plus 6 is 16, plus 9 is 25. Okay, so we have our 25 outcomes. If your fractions don't add up to your total number of outcomes, obviously you've done something wrong somewhere, whether it's your calculations or maybe you haven't really worked out the total number of outcomes correctly. So now we're going to move on to without replacement. Okay, so the scenario is going to be the same, but obviously the outcome is going to be different. So we have, again, 3 red, and we have this time 2 blue. Okay, and let's start with a red and a blue. We have 3 out of 5 as our first probability. We have a 40% chance of getting a blue, but because we have taken the counter out and we have not replaced it, then we no longer have 5 counters in the bag. We have 4. Okay, so out of the 4, because we've taken out a red, that leaves 2. Leaves that 2 out of the 4 to get a red. Okay, and I'm going to put in brackets a half because I want to simplify it. To get a blue, obviously we still have 4 counters left, but there's still only 2 because you've only selected a red out. So 2 out of the 4, which is also half, you have the 50-50 chance of getting a blue or a red the second time round. If you have taken out a blue first and you haven't replaced it, then you still have 3 reds remaining out of the 4 counters that you have left over. There's nothing to reduce that or simplify that fraction. And then if we were to choose a blue the second time round, because you've already selected one the first time, out of the 4 counters that are left, you only have 1 blue available, which is a 25% chance of getting a blue next and a 75% chance of getting a red next, provided you have selected blue first. Okay, so combinations: red, 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 blue, blue, red, and blue, blue. Okay, so there's your 4 different combinations, but obviously because we have 5, so remember, event 1, we have 5 possible outcomes. And then because we're not replacing the counter into the bag, the possible outcomes in event 2 is only 4. So that means 5 times 4, you only have 20 possible outcomes altogether. So here we go. If I want to know the probability of getting 2 reds in a row, we're looking at these two fractions. Okay, and so we'll go 3 over 5 times a half is going to be 3 out of the 10. And we're simplifying everything together. Okay, let's have a look at red and then a blue. Okay, so then we're looking at 3 over 5 times another half. So it's the same thing. 3 over 10 is the same probability. Okay, so if we want to work out what the probability of getting a blue and then a red, we're looking at 2 over 5 times 3/4, and the outcome is 6 over 20, okay, which is 3 over 10, okay? So out of the 20 possible outcomes, 6 of them is going to be blue and then a red. We simplify the chances, 30% chance. And then lastly, if we want a blue and then another blue, we're looking at 2 over 5 times a quarter, which is then 2 over 20, which is 1/10. Okay, so if we're looking at this, we want to make sure that all of them add up to 1 or as a whole. So we've got 3 plus 3 equals 6, plus another 3, which is 9, plus 1, which equals 10. So 10 out of 10 is equal to 100%. Okay, so 30% chance, plus another 30% chance, plus another 30% chance, plus the 10% chance gives you your 100% in terms of probability. Great. So that is your two-step experiment with and without replacement. Got any questions? Let me know. Otherwise, see you in the next one.